Paired subjects t-test. There's a worry that statisticians have that the samples aren't going to be random, that they aren't going to be indicative of the population at large. Suppose, for example, that we set up a test between two methods of teaching the material. One is taught in Mrs. Aaron's class, the other is taught in Mr. Baker's class. So we assign a bunch of students to Mrs. Aaron, a bunch of students to Mr. Baker. There's always the possibility that Mrs. Aaron's class will do better, not because the particular book or program she's using is better, but because she just had better students than Mr. Baker. That is entirely possible. So what you want to do is remove that worry, remove that sense of variation. One method for doing it is, instead of just randomly assigning half the students to one group and half the students to the other group, you give a pretest. You take the highest two scores. The highest score you put in Mrs. Aaron's class, the second higher you put into Mr. Baker's, and they count as a pair, and you compare how they do. You take the third highest, put them into Mr. Baker's class, the fourth highest goes into Mrs. Aaron's class, and you treat them as a pair. Fifth and sixth, seventh and eighth, and so on down the line until you've assigned all of the children. Now you look not at the scores as a whole, but how the individual pairs work. The variation that I like doing is the before-after study. Here we have 5 individuals. They had a score before they began a certain program, and then they're tested when they leave, and we see what the score is after they leave. Now, what we're going to look at isn't so much the scores themselves, but how the one score compares to the other for the same individual. And we're going to combine it into a single measure by looking at the difference of the scores. That's why you see a D here, the average difference. It's why you see a D here and here in the null and the alternative hypothesis. We're going to be measuring difference in score. You'll also notice that I've already filled in greater than, because unlike the book, I think that this is the easier way of doing it. I always assume a positive difference. Now, you might say that you expect the before scores to be higher. Some scores you want to rise, some scores you want to drop. So in this case, suppose that the claim is that the before score is higher. Now, over here, you'll notice I want to turn it into a positive number. So if before is higher than after, I'm going to let D, the difference, be before minus after. If I thought that after was higher, then my difference would have been after minus before. Now I can go down the list. The difference here is 15, 5. The difference here is 1, but actually in the wrong direction. So if I take 164 minus 165, I get a negative 1. You expect mostly positive numbers, but don't be surprised by some negative numbers. Here the difference is 12, and here the difference is going to be 17. So I've found my differences. I'm going to try to put them into the calculator. So let's see, I go Stat, Edit. Let me get rid of these numbers from an earlier attempt. In list 1, I'm going to put in the numbers on top. So that would be the 179, the 184, the 164, the 190, and the 208. In the other list, I'm going to put in the 164, the 179, the 165, the 178, and the 191. Actually, you could just put in this line. I'm only showing this technique with the two lists separately in case you don't want to trust yourself to do all of the subtractions correctly. It's so that I can show you something you might not know your calculator can do. I go to the third list. I move up to the header of that list. And now what I type in, if I want before minus after, I'm going to type in second 1 to get a list 1 minus second 2 to get a list 2. That tells the calculator that you want list 3 to equal the value in list 1 minus the value in list 2. And you'll notice that I get my 15, 5, -1, 12, and 17. So the calculator can do the subtraction for you if you're not comfortable doing it yourself. From this point, it's just a straight t-test. Stat, tests, 2. We're doing it with raw data. Mu naught, our hypothesized mean, was 0. The list that we put the information in, well, list 1 was before, list 2 was after, so list 3 is the difference. Frequency, for this class, always leave at 1. And for the inequality, we did use greater than. So I'm ready to calculate. I get a t-value of 2.874. 3 decimal places because t and z are test statistics. I get p is 0.023. Now remember, if no alpha is specified, the default value for this class is 0.05. Since 0.023 is less than 0.05, we would reject the null hypothesis. Since I gave raw data, I like you to give me back summary statistics. X bar was 9.6, but remember that I prefer that you call it D bar, and N is the number of paired results. So in this case, N would be 5. I'm less interested in S, but if you want, you can say that S is 7.47. That is optional. I sometimes, but more rarely, ask the follow-up question, and here you could just take the t-interval to find out how big the difference is. But this is going to be a paired subjects t-test. It is similar but different from the other tests we did, and that's really the challenge in this next test. You'll notice that the reports all look very similar, but there are slight differences in how we handle each of them.